Hey YouTube, thanks for visiting my channel. This is Chandan and in this video we are going to solve some questions of West Bengal set 2022 and this is the questions from statistics. Okay. So in the last session of statistics solution we solved up to the question this is a questions from Markov chain and I think we already solved the 7 to 8 questions of WBCSC exam from statistics background, and the mathematical questions are already solved this papers 2022, 2020 and 2018. Okay, so in this session we are going to solve some questions of statistics again. Okay, so let's start, and before starting we are requesting to you, those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, so our first questions of today's session is this one. This is question number 99 from X series. Okay, and this is, I think, the Y series number is what? The 56. Okay, so it says that a two component series system consisting of independent and identical components following the exponential distribution with mean 2, the failure rate of the system is. Okay, so first we have to identify from which these questions is made. Okay, so this is a questions from reliability theory. Reliability theory. This session or this topic is also important for CSIR NET. Okay, every year a questions of 4.75 marks comes in the CSIR NET exam. Okay, I already take a class on reliability theory in my channel. You can also visit for these questions. The concept of these questions also included in that video. Okay, so I think I take a session reliability theory session 1. Okay, so you can check this video in the playlist, okay, or in the video section. Okay, so it says so first we write what is the PDF of exponential distribution. So fx, this is equal to, we can write theta x to the power minus theta x for x greater than 0 equal to 0. Otherwise this is the density function of exponential function. Okay, and the mean this is equal to of the exponential distribution is 1 by theta and variance equal to 1 by theta square, and we only need here the mean value. Okay, now it given that with mean 2, that means fx equal to what? Fx equal to this is 1 by 2 x power, sorry, I think this is exponential power, sorry, exponential minus x by 2. Okay, so this is the density function of the given distribution. Okay, now we have to find what the hazard rate function or the failure rate, the hazard rate, that means the value, this value ht. Okay, you get this ht in my video, you can check, you must check this video of reliability theory, one video, and you can get all the topics and all the concept of reliability theory. You must watch this. Okay, so now we find the distribution function capital Fx. This is equal to integration 0 to x, okay, and fx dx. So we all know that how to calculate the distribution function from the density function. So this is equal to, suppose we change this variable, then another variable, suppose e. Okay, so this is equal to integration 0 to x exponential minus t by 2 dt. Okay, so this is equal to integration exponential minus t by 2 by 1 by 2 minus into 0 to x. Okay, so this is equal to 1 by 2 and 1 by 2 going to be cancel out here, and if we put the limit, then we get this is equal to 1 minus exponential minus of x by 2. So this is the distribution of fx. Now the reliability function rx equal to, we all know that 1 minus fx. So this is equal to x to the power minus x by 2. Okay, now the definition for hazard rate function, this is hx, this is equal to what? Is fx by rx. Okay, so fx by rx means what? Fx means this one, so half e to the power minus x by 2 by exponential minus x by 2. So this is equal to simply half here. Okay, so the hazard rate function is what? Half. So this is the hazard rate function. Now for a two component series system, this is very important note, you can say also, this is a very important note. that for a two component series system, the hazard rate function, if there are n component, okay, n component with a series system, n component series system, and the hazard rate functions are suppose h1t, h2t and hnt of each component, okay, then the hazard rate function of the system ht, this is equal to h1t plus h2t plus product plus hnt. This is theorem, and you can say, or note, or you can say, okay. So here we get two component each with hazard rate is half, therefore here our answer is half plus half is equal to 1, okay. So 1 is our answer. So option number B is correct here, okay. And all the concept of these questions is already discussed in the class of reliability theory, so you can check my links, okay, or check the videos available in the channel of videos, the video section, okay. Now going to the question number 85. So this is also a very important question. So it says that suppose xn n greater or equal to 1 is a sequence of random variables on the probability space, which of the following statements is always correct, okay. So first we identify from which this question is made of, okay. So this question is made from the limit theorems, which is a very important chapter for probability, okay. This question is based on limit theorems, okay. So, and which of the following statements is always correct here? Here we need two theorems, or one theorems, I think one or two theorems. First one is, what is this means as and this p. So this p means probability, okay. That means xn tends to x, xn converges to x in probability, okay. And this means as means xn converges to x almost surely. So this means almost surely, okay. So now what do we mean by this almost surely? So first we write the definition of almost surely. So let xn be suppose xn be a sequence of random variables. I just avoid. Now the definition of almost surely convergence is that, suppose this is a variable omega, okay, they such that the random variable xn omega, okay, so this is tends to x omega. So this is the convergence such that as n tends to infinity, as n tends to infinity, and this convergence probability equal to 1, okay. So this is the definition of certainly, almost surely convergence. But if we write this is convergence, this is the definition of convergence in probability, and if the probability is 1, okay, then we say that this is almost surely convergence. So here one thing you can clear, that probability convergence in probability, this implies convergence, I write the wrong thing. So convergence almost surely implies convergence in probability. Why? Because this is only case when probability equal to 1, but this is the total case such that this one, okay. So we can say that because probability lie belongs to 0 to 1, okay. So and in the only case probability when 1, then this is the definition of almost surely convergence, okay. So this is the definition. That means we can say convergence almost surely implies convergence in probability but not conversely, okay. I think this is clear. That means this option A is not correct. It says the उल्टा पार्ट बोला है यहाँ पे, ठीक है. तो देखो ऑलमोस्ट सर्टेनली, दिस मीन्स दिस प्रोबेबिलिटी इज 1 ओनली एंड दिस implies the convergence in probability, because probability 1 is a particular case of the total probability, you can say like this, okay. So this is completely wrong option. Now and another theorem here, we need let what xn be a strictly decreasing sequence. decreasing sequence of positive random variables okay. Suppose xn converges to x in probability, then what happened? Xn converges to x almost surely. This is the theorem. Okay, that means we need only monotone decreasing part, and here it is given the monotonic sequence, but we can say monotone decreasing or strictly decreasing is a case of monotone only. Okay, monotone. Okay, that's why option B is correct here. And if you say other options, then xn tends to x in law, then xn tends to x in probability. No, this is incorrect. The converse part is true here. If xn tends to x in probability, then xn tends to x in law or distribution. Okay, so this C option is incorrect here, and it is also D option is also incorrect. The correct option is answer B. Using this theorem for these questions or for this limit theorem, I can suggest the book V.K. Rodigi. Okay, this is the spelling V.K. Rodigi. This is the very good book for statistics. Okay, you can check this. So now question number 92, for a BIBD BVRK lambda, which of the following conditions is sufficient? So what is BIBD? Okay, so first we have to identify the questions from which the question is made of. Okay, so this is a questions from sampling survey. Sorry, this is not sampling survey. This is from design of experiment. Okay, so this is the design of experiment. This question made from this chapter, design of experiment. And BIBD means what? BIBD means just a minute. Balance of BALAN, balance incomplete block design. Okay, so and here the theorem or the definition of this BIBD is what? Now we say that always remember this thing, a design D. Okay, the session these variables are in not correct order. We can always write BKVR lambda. Okay, so a design of this BKVR lambda is said to be a BIBD if it satisfies the following conditions. Number 1 is BK equal to VR. Number 2 is lambda into V minus 1. This is equal to R into K minus 1. And number 3 is B is greater equal to V, and hence we can write what? R is greater equal to K. But it says that which of the following is sufficient condition. These are not the sufficient condition. These are the what? These are the necessary condition. This is also don't need this option. Okay, that means these three are wrong. That means the information is insufficient. Okay, so this is the definition of BIBD. And these are the necessary conditions for a design is to be balanced incomplete block design. Okay, so option D is right here. Now going to the next question, the question number 88 from X series, the mode of the geometric distribution with probability mass function. So this is geometric distribution. So this is the chapter of spatial discrete distribution. Okay, spatial discrete distribution, Poisson distribution, geometric distribution. Okay, these types of distribution, binomial distribution, these types of distribution are called discrete distribution. Okay, now the PMF of this distribution probability, this is equal to q to the power x into p, where x is equal to from 0, 1, 2 and so on, and what p plus q equal to 1, you all know that. Okay, now the mode of the geometric distribution, here you can write a note. The mode of the geometric distribution is 0 if this p lies in between this interval. Okay, now if we see the probability mass function, then we can write this q to the power k type form. Okay, that means this half is p, the value of p and the value of q, you can say like this. Okay, so this is half to the power k. This means the value of p lie between this, and this is obviously true for the geometric distribution because this p and q value always lie between 0 less than p, q less than 1, since p plus q equal to 1 here. That means what, the mode of the geometric distribution is what, 1 here. Sorry, this mode is 1. Okay, I think I write correct one. Okay, so this is the concept behind this question. Okay, going to the next question, and this is the last question. So what is the question? Question number 73. It says that if x is distributed exponential with mean 5, and this is a question from distribution special continuous distribution. Okay, special type of continuous distribution, you can say. Now we first write what is the PDF of exponential distribution. So if x follows exponential distribution, then the PMF fx equal to exponential theta, you can say parameter theta, then this is equal to what, fx equal to 1 by theta, theta exponential minus theta a keeps x greater than 0. Okay, now we need only another note also, which is this exponential distribution satisfies the, or the exponential distribution is also called lack of memory or lacks memory. Okay, why, if x follows this distribution, then for any a greater or equal to 0, this we can write probability of y, any y less equal to x. Okay, so given x greater or equal to a, this is equal to probability of x less equal to x. Okay, so this is the lack of memory property, lack of memory property. Okay, so where y equal to x minus a. Now we first see this option. So, and one more thing is that what, probability of x less equal to x, this is equal to what, this theta integration 0 to x exponential minus theta x, suppose there is another variable t into d. Okay, so this is the definition. Now it is given that x greater or equal to 6, so probability of x greater or equal to 6 given x greater or equal to 5, so this is equal to, we can write 1 minus probability of x is less than 6 given x greater or equal to 5. Okay, so this means what, from this definition we can write what, 1 minus integration, see, probability of x less equal to 6, that means we can write integration 0 to 6, but here one condition is given, x greater or equal to 5 is already occurred, that means we don't need this part, so we integrate here integration 0 to 5. Okay, and e to the power minus what, and one more thing, from here it is given that it follows exponential mean with mean 5, that means the from the question the distribution or the density function is what, 1 by 5, and integrate exponential what, minus 1 by 5x, just like the first question in this session. Okay, so integration 1 by 5 exponential minus 1 by 5 x in t, this is dt, and you can say another variable also. So this is equal to 1 minus 1 by 5 into e to the power minus 1 by 5 x by, or t, any other variable, so minus 1 by 5. Okay, so this one, So this goes to cancel. So this is equal to 1 minus, and this is the integration from 0 to 5. Okay, so this is 1 minus exponential minus, simply here we write t or 1 by 5 into 5. So this is equal to 1 minus 1 plus e to the power minus 1. So this is simply e to the power minus 1. So it says that which of the following option is not true. So first option is not true option. We don't need to check the other options. Okay, this thing also you can check. This is a special property. If x follows exponential 0, exponential 1, exponential 1, then the distribution fx follows uniform distribution with discrete uniform distribution with 0 1. Okay, this is the property you can say. But here it is given that it mean 5, therefore minus x by 5 is the exponential 1 distribution, you can say easily from these results. Okay, so these are the questions for today's video. So if the session is helpful, then please give a like to this video, share with your friends and subscribe the channel. Thank you friends, see you again in the next video. Thank you.